Hello everyone, you are watching studyhub.world. So today I am here to share with you all my PhD interview experience at IIT Delhi. I will tell you the questions that I faced in my interview and what was my response to them. Overall, it was a great experience for me. Hope this video will help you. So let's start the video. My interview was in the morning session, and when I joined the meeting, there were 6 to 7 professors in the panel, and they asked me questions from different subjects. Basically, they asked me plasma physics, statistical physics, electromagnetic theory, and nuclear physics. And one of the professor asked me, what do you understand by plasma? Most of the time they asked me questions from plasma physics because this is my area of interest to do the research. So I explained that plasma is a quasi-neutral gas that contains electrons, positive ions, and neutral atoms, and also it shows collective behavior. And after that he asked me that what do you mean by quasi-neutral here? So I explained that quasi-neutral means that plasma has a unique property of creating charge neutrality, maintaining its charge neutrality at every macroscopic volume. That is why we call it as quasi-neutral gas. So then he asked me that how can you differentiate between ordinary gas and plasma? So I explained that both the ordinary gas and plasma contain free particles, but in ordinary gas, these free particles are not the charged ones, they are neutral atoms. Okay, but in case of plasma, these free particles are charged ions and electrons. So this is the basic difference between plasma and ordinary gas. Then he asked me that when we need confinement of plasma, and what do you understand by this term? So I explained that plasma confinement is used in thermonuclear fusion, especially in fusion reactors in which fusion take place at a very high temperature of range 10 raised to power 8 Kelvin, that is even more than that of sun's core. So at to carry out fusion at such a high temperature, confinement of plasma becomes necessary. Okay, so then he asked me that what is the effect of magnetic field on plasma? So as plasma behaves as a diamagnetic material, magnetic field has a very significant effect on plasma, and it is basically used to confine plasma. Okay, it exerts a force on plasma when we apply magnetic field around it, so it is used to confine plasma. After that he asked me that what are the applications of plasma. So I explained that plasma is prepared in the laboratories also, and also it is present naturally. It is occurring in sun, that is fully consist of plasma state, and also it is present in the outer earth's atmosphere, that is ionosphere. Okay, so in laboratories also it is prepared to do the fusion, like it is used in the fusion reactors. Also, one of the major project that is still in process, ITER project, is also one of the application of plasma. So then another professor asked me that have you heard about sheath resin, please explain it. So I explained that sheath area, or we can say depletion resin, is the resin in the plasma that whenever we start to insert any charge from outside into the plasma, okay, then due to its property of quasi neutrality, it has a special property to maintain, to surround that particular charge with an equal and opposite charge, so that it can have charge neutrality at that particular volume. So that region is called as sheath region. Okay. So then they asked me that what do you mean by pinch effect? So actually pinch effect means that whenever we apply perpendicular magnetic field to the plasma, okay, that is magnetic field in a direction perpendicular to that of plasma, then plasma pinches towards the center, means it bends towards the center. As it is, we can see in this figure, it appears somewhat like this, that it pinches towards the center. That is what we call as pinch effect. Okay, means it is repelled by the magnetic field. Then they asked me questions from statistical physics also. Firstly, one of the professor asked me that what are fermions and bosons. They start from very basic questions, like I explained them that fermions are the particles which have half integral spin and they obey Fermi direct distribution, and bosons are the particles which obey Bose-Einstein distribution and they have integral spins. Like now we know that photons have integral spin and electrons have half integral spins, so they are fermions. Okay, so next they asked me that what do you mean by here Fermi direct, or we can say Bose-Einstein distribution, what these terms represent actually. Before this also they asked me that simply tell us what do you mean by distribution function. Okay, so I tell them that distribution function explains us actually the probability of occupancy of something. That is, here we can say that distribution function tells us the probability of occupancy of any energy state, that how much that energy state is occupied. Okay, so when we come to Fermi direct distribution, then it represents that what is the probability of occupancy of any energy state by fermions, and in Bose-Einstein distribution it is the probability of occupancy of any energy state by bosons. Okay, then they asked me that what statistics does plasma follow and why. They also said me that we know that plasma actually contains electrons and ions. Okay, so they also contain, means they also contain electrons. So why they are what statistics they obey. So I told them that they obey Maxwell-Boltzmann distribution, Maxwell-Boltzmann statistics. But then they said that actually plasma contains electrons, so why it does not obey Fermi direct distribution. So I didn't know a very exact question, exact answer to this question, but I give them a very brief answer, that whenever we know that plasma, in plasma the energy is directly related to temperature, that is it is directly proportional to temperature. It is, the temperature is measured in terms of electron volts. Okay, that is same as we see in Maxwell-Boltzmann distribution. In Maxwell-Boltzmann distribution also energy is simply expressed as kT, half kT, means it is directly proportional to temperature, but it is not like this in Fermi and Bose-Einstein distribution. So this is one of the reason that plasma follow Maxwell-Boltzmann statistics. Okay, they asked me questions from electrostat, some basic questions they asked me from this. Like they asked me what do you understand by Coulombic potential, or what is the variation of potential for a point charge. So I tell them that for a point charge, potential is inversely proportional to the position vector, which we say as r. For a point charge, potential is inversely proportional to r. Then they asked me that what is the electric field inside a hollow sphere and a solid sphere. So I explained that inside a hollow sphere we have zero electric field, and in the solid sphere the electric field is directly proportional to r. Okay. Then one of the professor asked me that if we place electrons all around a positive charge, then what will happen? So this I explained that whenever we place a negative charge in the influence of any charge, then it experiences a force in a direction opposite to that of electric field. So as we know that for a positive charge, electric field is readily outwards. Okay. So as we have placed electrons that are negatively charged around a positive charge, so they will experience a force towards the positive charge. Okay, that is in the direction opposite to that of electric field. Okay, so at last they asked me some questions from nuclear physics also. One of the another professor asked me first that what do you understand by fission and fusion. So I told them that fission means when a heavy unstable nuclei splits into two or more small nuclei with the release of energy, we call it as fission. And when two small nuclei fuse to give a heavier nuclei with release of huge amount of energy, that we call as fusion. Okay. And then he asked me that why fission and fusion takes place, what is the reason behind this. So I explained them that the answer for this question is by we can give it through binding energy curve, that is physical significance of binding energy curve. The curve explains us that when the for the two lighter nuclei and also for two small nuclei fuse to give a heavier nuclei with release of huge amount of energy, that we call as fusion. Okay. And then he asked me that why fission and fusion takes place, what is the reason behind this. So I explained them that the answer for this question is by we can give it through binding energy curve, that is physical significance of binding energy curve. The curve explains us that when the for the two lighter nuclei and also for the heavier nuclei, the binding energy per nucleon is small, but for the intermediate size nuclei the binding energy is large. So that is why more is the binding energy per nucleon, more stable is the nuclei. So that is why the small nuclei fuse to give some large nuclei, okay, so as to increase their stability, and also heavy unstable nuclei splits to give a small nuclei, they also want to increase their stability. Okay. Then he asked me about the semi-empirical formula, about the different terms in the semi-empirical formula, like the 5 terms like pairing energy term, volume energy term, then symmetric energy, coulombic energy. So all these terms I explained, and also he asked me what is the significance of each term. Then he asked me that as we know that in a nuclei we have proton repulsive forces, so what is the reason that binds the protons together inside the nucleus, what are the forces that are responsible for this. So I explained them that due to the presence of nuclear forces, the protons are present inside the nucleus and they are stable also. So this is due to the presence of nuclear forces. Okay, so these were the questions that I faced in my interview. One thing I want to say that if you're watching this channel for the first time, then please subscribe to my channel, and also if you found this video really helpful, then please press the like button, because this encourages me to put more videos.